Hello everyone. Today we discuss bipartite graph in discrete mathematics and complete bipartite graph. Okay. So first of all, bipartite graph. So in loop-free graph is equal to v comma e is said to be bipartite graph if it is possible that the vertex at v can be decomposed into two disjoint subsets V1 and V2 such that every edge Vi, Vj connects a vertex in V1 and a vertex in V2. That is, there is no edge joining two vertices inside V1 and or V2. Okay, so for example, if we have one set of vertices V1 and V2. Okay, another set of vertices U1, U2, U3. Okay, and there is an edge to join these vertices like this. If it is connected with this, okay, this is connected with this and like this. Okay, so this is called bipartite graph. Okay, if we talk about complete bipartite graph, so first I will write its definition, then I will show you how we can draw any bipartite graphs. Okay, so let us start complete bipartite graph. So a graph G equals to VE is called a complete bipartite graph if its vertex set V can be decomposed into two subsets V1 and V2 such that each vertex V1 is connected to each vertex of V2. That is, there is an edge between each pair of vertices in V1 and V2. Okay, so if number of vertices in V1 is m and number of vertices in V2 which and then such a graph is denoted by KMF. Okay, and remember one thing, complete bipartite graph Km, n has m plus n vertices and m into n edges. Okay, for example, so let us see the example. If we have three vertex in V1 and three vertex in V2, like, okay, this is U1, U2, U3, and likewise this is V1, V2, V3. Okay, so for complete, U1 must be connected with all three vertices like V1, V2, V3. Likewise, U2 must be connected with V1, V2, and V3. Okay. Likewise, U3 must be connected with all three V1, V2, and V3. So, in the first vertices we have set of vertices we have three, and in second we have three. So, this is the K33 complete bipartite graph. Okay. So, you can see here total number of vertices are 6 and total number of edges will be 9. Okay. So, question may be asked to draw the bipartite graph, yeah, complete bipartite graph. Okay. So, for complete bipartite graph, each vertex should be connected to other sides. But in bipartite graph, there is no need to connect all the vertices. Okay. So, let us do some questions regarding this. Yeah, related to this. So, you can see. Question is that draw the bipartite graph K24 and K34, assuming any number of edges. Okay, so you can see here K24, it means in the first set of vertices you have only two vertex. So let us imagine these are V1, V2. And for second one, these are four. So you can write U1, U2, U3, U4. Now you can connect, but there is no condition that you have to connect to all four vertices. Okay, you can connect either by this one. Okay, so this is the bipartite graph. Is that clear? K24. Okay, if you draw the graph for this one, so for the first one you need to draw three vertices, that is V1, V2, V3, and for the second you need to draw four vertices U1, U2, U3, U. Okay, now connect. You can connect any vertices to any. Okay, like by this. So this is the bipartite graph. K, 3, 4. But if we have to draw the complete bipartite graph, then you must be connected to each vertex. Okay. So let us do one question regarding complete bipartite graph. Okay. So let us draw the complete bipartite graph K25 and K16. Okay. So just see here. For first one, K24. So there is first two vertices is there. You can write V1, V2, and here 5. So just draw it. Okay, 1, 2, 3, 4. Connect V1 to each vertices. That is like this. Okay, suppose this is V5. You can name it. This is U1, U2, U3, U4, U. Okay, also connect V2 to each. Okay, so this is complete bipartite graph K25. Okay, for second one, here is only one vertice and here is 6. So U1, U2, U3, U4, U5, U6. Okay, connect V1 to each. So this is complete bipartite graph K16. Okay. So this is all about bipartite and complete bipartite graph. If we talk about regular graph and complete graph, so you can see now. Complete graph. A complete graph, it is simple graph G equals to VE, where for all vertices Vi, Vj belongs to V, Vi is not equal to Vj. Okay, so there exists an H. Okay, Vi, Vj. For example, yeah, in other words, we can say that a complete graph, every vertex is connected to each other. Okay, in complete graph, every vertex is connected to each other vertex. That is, every pair of different vertices are adjacent. For example, complete graph for one vertex only K1. For two vertex, there may be only one K, so this is K2. Likewise, if you calculate K3, so this is just like, so here also each vertex is connected to each other, so this is K3. So in four vertex, you can see that if we have this graph, so now these two vertices are not connected to. If we connect these two also, then it will be complete graph. Okay, and this is called K4. Likewise, we can calculate for 5 with 5 vertices. Okay, like this. So we need to connect each vertex to each other. Okay, likewise, we have to connect this one with this. Okay, this one with this one with this, like, so this is K5. Okay, so this is complete graph. Now the next thing is regular graph. In graph G equal to VE, it's said to be regular if each vertex in G have some have same degree. Okay, so if we graph G is regular with degree of VAR for each vertex V in G, then G is called R regular. Okay, for example, you can see here if we look this graph, okay, it have four vertices V1, V2, V3, V4. So if we find the degree of V1, that is two, only two vertex are connected. Yeah, there is only two edge between these two. So V1 is 2 also, degree of V2 is 2, V3 is 2, likewise V4 is 2. So each vertex have the same degree, so we can see that it is 2 regular. Okay, so this is about the regular graph. Okay, so it is enough for today. Okay.